Hi, dear students. Good afternoon. Today I'm going to continue for lesson 4, pages between 259 to 264. Okay, the topic is hydrocarbon structure and isomerism. There is first of all there is one section for naming of hydrocarbon structure, naming of alkanes and alkenes. So it's better you have a look for YouTube videos that I attached in this post. They You can learn more, and those videos are more complete for YouTube. So we save time and we move to isomers. Isomers are two or three or four or five compounds, are a group of compounds that have same molecular formula but different structure. Okay, so isomers can be defined between two structure or three structure that they have same molecular formula. That means same number of carbons, same number of hydrogen, same number of any atoms, but the arrangement of the atoms are different. The arrangement of the elements and the structure are different. So here, for example, we have butane and we have 2-methylpropane. The molecular formula is same, C4H10. That means there are totally four carbon and 10 hydrogen atoms. But the arrangement in the structure, molecular structure, is different. In butane, um, the, it's a long chain. Okay, the structure is long chain, but in 2-methylpropane, there is a branch. Okay, one methyl group attached in the center, in the carbon number 2, and make another branch. So this is not a very straight chain like a butane. If you look carefully uh, to the temperature that they can be liquefied, you can see that butane liquefies in 0 Celsius, and 2-methyl propane liquefies in minus 12 Celsius. So there is a difference between these two structures. At the left, you can see a very straight chain. At the right, you can see alkane, which has a branch, which has extra branch. Not extra, but this is branch. Is form of the branch. But these structure difference affects on melting point. Okay, next slide. You can see that the most important difference between isomers is melting point and boiling point. Okay, there are many similarities between isomers, but the most important difference that it's a very obvious and you can identify between isomers is based on melting point and boiling point. There is one rule that you need to keep in your mind, is that more branches is lower melting point and boiling point. So if you look back to this slide, you can see on the right, this structure has more branch, like this one. Okay, there is more branch, and it has a lower boiling point and lower uh, melting point. Okay, lower melting point and lower boiling point if the isomer has more branch. So next slide, I put here two example between alkanes. Okay, there is a double bond, as I explained at last session. These are alkanes derivatives are isomers. This is the best name, isomers. Three isomers, one butane, two butane, and two methyl one propane. All these three are isomers. They have same molecular formula. That means they have same number of carbon and same number of hydrogen atoms. But as we can see, 2-methyl 1-propan has more branch. Okay, it has one branch, but actually the other two are a straight chain. Okay, they are just a form of chain. So we can guess which of these three has lower boiling point and lower melting point. Of course, is 2 methyl 1-propan. Another example is the isomers between um, pentane, 2-methyl butane, and 2,2 dimethyl propane. And these are also three isomers. These three isomers have same formula, molecular formula, but different structure formula. The structure are different. And another thing is melting point and boiling point. Which one has the lowest value? The lowest value is belong to the 2,2 dimethyl propan, because this structure has more branch. Okay, there are, like, if you see, this is very straight. This one, if it's a straight chain, so you can see the other two branch here. This structure has only one branch. Okay, and this structure, it's just a straight chain. And okay, here I did one. uh, okay, this one is chemical reaction. Okay, chemical reactions of alkanes. Actually, here, yeah, this slide is better. Mm, we are going to look at two important reactions. One is substitution reaction, and the second one is addition reaction. Okay. Substitution reaction is belong to alkanes. That means alkanes alkanes follow substitution reaction, and alkanes follows addition reaction. What are these reactions? The first one, um, there is a replace. Okay, there is a replacement between two reactants. We have RH. R means alkane, any chain, alkane chain, like methane, propane, butane, or any. Okay, just put R. Of course, at the end of the chain there is a hydrogen. Okay, like you can see here. Okay, end of any alkane structure there is hydrogen. Okay, so this is only a symbol. They write it like this in organic chemistry. This is well known for every chemist. The second reactant breaks down, and the A and B can separately react with the alkane. Okay, so the alkane also can be the bond between hydrogen and alkane can be breaks down. Okay, can be broken and react with each of A or B. So the result shows you two products. One product, is the part of A which reacts with R, and the second product is the part of B which reacts with hydrogen from alkane. Okay, this is substitution reaction. That means there is a replacement. Okay, these two reactants, the what we call the part of reactants, can replace with each other. But in addition, which happens in alkane compounds, there is no replace. Just the second reactants, like here A, B, can add to the double bond. In alkane, we have double bond. This is very important part of alkene structure. I explained before that alkane, the double bond, can be named as a functional group. Actually, the function of alkenes compounds comes from the double bond. Okay, so addition, both A and B, the two parts of second reactant, can be added in each side of double bond. Okay, A react with the double bond and placed in this the first carbon, and B also react with the second carbon and placed here. So finally we will have one product. Okay, we will have one product, not two or three, because they combine to each other. They and the second reactant attach to the first reactant. Okay, let's to open this reaction, and let me to give you more example. Chemical reactions of the alkanes, I said that they follows substitution reaction. Okay, there is two examples for this type of reaction. One is combustion and second is halogenation. The first combustion is the like as an example is a burning of fuel, burning of the gas that we daily use in our home when we are cooking, or when we burn the fuel by motorcycle or in our car. I gave this example in last session. I said if we have enough supply, if we have enough air supply, that means enough oxygen, so the reaction would be complete, and butane react with oxygen. Then finally the products would be carbon dioxide and water. If the reaction place is very, is very hot, and if it's happened in hot environment, the water would be boiling, and would be leave the reaction as a vapor. So this is same for all alkanes, even butane or propane, um, ethane. It depends on based on the number of carbon in alkanes, you will get different amount of carbon dioxide. For example, you have two butane, you will get eight carbon dioxide. It depends. If you, for example, use hexane, that means C6, you will get more carbon dioxide. It depends on which alkane you use. But on the other hand, if there is not enough air, that means air supply, or if there is not enough oxygen, you can see that you will get carbon monoxide. Okay, carbon monoxide is very poisonous, and uh, you can refer to the chapter 1, lesson 1. And carbon monoxide is considered as poisonous gas, which is very dangerous if you face with these high concentration of carbon monoxide. And the second example of substitution reaction for alkanes is halogenation. Um, Book gives only one example from the chlorine, but halogen atoms, um, halogen atoms are included fluorine and chlorine and bromine and iodine. So methane, as we know, methane is alkane. Okay, methane if reacts with chlorine in presence of sunlight. Okay, this reaction is substitution reaction and it follows this general pattern that I explained. So chlorine can be break down if there is sunlight, or in laboratory uh, sunlight can be replaced by UV light or or another light, which is alternatively UV can be used. So sunlight or any other related light can break down the bond between chlorine and also RH here. This is RH, this is carbon RH, same. Okay, R can be defined for any alkane chain. So here can be breakdown, can be broken down, and also AB coloring can be broken down, and then each part can react to each other, and actually this is a replaced reaction. So the finally you will get chloromethane like this, and hydrogen chloride. This is the hydrogen, only one hydrogen, which is joined to uh, chloride. These are also the reaction based on the atomic name, CH4 and chlorine and chloroform. This name is chloroform, and hydrochloric, but in form of uh, hydrogen chloride in form of gas. Okay, let's move to chemical reaction of alkenes. I said that alkenes follow the addition reaction. Addition reaction, the general pattern, general reaction you can see here. Okay, of course there is a double bond in alkenes structure, and we have another reactants that can add to the double bond and make the double bond to a single bond. First example is bromination, but this is from your book, this word, but I think uh, other halogen atoms like fluorine or chlorine also, they can carried out this reaction. It's not only from bromine, but I'm just following your book. Ethylene can react with bromine, and bromine can the bromine bonds and can be broken down, and each bromine atom can place on the carbon in the middle. I mean, each two side of a double bond. So the double bond can be changed to a single bond as make it alkane structure. Then next example is hydrogenation. Instead of halogen atom, if we have hydrogen gas, so that would be same attitude, same reaction. Hydrogen can saturate the alkenes. We have double bonds, and we have alkenes, like here the example is ethylene, and uh, after after react with hydrogen, it changed to ethane or alkane actually. So hydrogen only change the double bond to the single bond. Then each carbon, instead of two hydrogen, can get three hydrogen. The example from your book is here, ethene, and with reaction with hydrogen, you will get ethanol. Okay. Actually, this is I took from the internet. This is wrong. It's not ethylene. Okay, this name is not correct. This is correct, ethene. This one is ethene. Okay, this one is ethene, not ethylene. This one is ethene. When ethene react with hydrogen and change it produce ethane. Okay, ethane is alkane I mean, and ethene is alkenes. So let's move to the last example, last reaction of the alkanes is hydration. Hydration means adding water. If we have water, and if you break down the water to two parts, you can get one hydroxyl group, and another is hydrogen group. So this reaction can be uh, should be carried out in presence of any acids like sulfuric acid or phosphoric acid. Any acid you need to add to this reaction. Acid can help to separate your water molecule. When you have the acid, when you have any suitable acid in your reaction, the acid can help to separate the water, and the reaction can be carried out faster. So one part is hydrogen and another part is OH or hydroxyl. So these two parts attack to uh, double bonds, okay, and they break down the double bond to only single and change it to single bond. The example is ethene. Again, we have ethene um, reacting with steam. Steam meaning hot water. They make it hot water to give a heat and to make the reaction faster. And in presence of phosphoric acid, here they use phosphoric acid, and then finally you will get ethanol. Ethanol is a type of alcohol. Okay, here you can see the reaction between alkenes and water, you will get alcohol. Okay, if you have any derivatives, any alkenes structure, and if they react with water in presence of acid, you will get alcohol. Alcohol has own special reactions and properties that I will explain you next session. So that's it. That's all for today. But please have a look at the questions. I set some question related to our topic. This is the first question, and second question. You can pause the video and write down on your notebook and think about it. Try to find the answer and leave the comment for me. I will check it. And then question number 4, which is related to today's reaction. And question number 5, this is the first part, It starts from here, then shows you the equipment, tools, and then here, and ask you the question. Okay, take care. See you soon. Good luck.